is designing a data model for a ride-sharing service app. Hello, everyone. Welcome to another data engineering mock interview with Exponent. Today, we are going to talk a little bit about data modeling with our guest, Kajal. Thank you so much for being here, Kajal. Would you take a moment to introduce yourself to our viewers?
Yeah, hey, my name is Kajal. I work as a data engineer in Uber. I've been working in that company for a while. Uh, we take care of everything from requirement gathering to data modeling to uh, ETL design, and then finally the implementation part of it. And of course, the data modeling plays a very, very key role when it comes to the the pre and the pro post, because eventually you want your users to be able to query your data in the most optimized way, and data design is actually the core of it. If your design is not accurate, uh, the query performance will never be accurate at the end of the day, actually. So yeah.
Exactly. So we are going to do one such data model today.
If you're enjoying this video, you can watch dozens more of videos like this at tryexponent.com. Check out our real interview questions with full written solutions. Over 1 million people use Exponent to ace their interviews in product management, software engineering, engineering management, machine learning, data science, and much, much more. Get started for free at tryexponent.com.
Let's just jump right into our question for today, which is designing a data model for a ride-sharing service app.
So we are creating a ride sharing app. So my understanding of this ride sharing app is that we want to build data model for basically a service app which allows the users to book cabs via the app, and basically the driver comes, picks that user, and then drops them to a desired location, right? That
Yep.
is the expectation is, right? From this, I have three outstanding questions, actually. What are the use cases? Second is, who are the users? Uh, and what are the impact of these use cases?
So yes, let's tackle one by one. What are the use cases? So my use case is twofold. One is going to be more operational specific. I would like to understand the driver conversion rate. By driver conversion rate, I'm meaning the optimizing the driver onboarding process from sign up through to the activation. So as you can imagine, there could be a lot of steps in between. So I would like to know how we can optimize the driver onboarding. The second is more trip specific. I should be able to understand the trip requested, how many the trip completion rates for the user, and you can spice it up with more additional details if you want.
User actually makes sense. Okay, these are the use cases, and who will be the users for these?
Okay, so the users could be so for like I said, the operational metrics would be useful for data used by data analysts, machine learning engineers, or operational personnel as well, or even for business optimization purposes to get the driver onboarding time
So basically,
less.
we're looking at data analysis, right? That
Data
is.
analytics, yes, basically.
Okay. And could you share the impact, like what would be the impact of these use cases so as to um, like once you build these data models, and then how will these
Yes, that's a good question. So the the immediate impact which I could think of is like a business for the first type of use cases is a business optimization. So I would like to get the driver onboarding time lesser. The more metrics and the more pain points we could understand, the better. The second is more trip related data that can directly contribute to the profits or improving the business, understanding where the trips are going well, and more importantly, where it's not going well, and any other analytical points that we could gather.
basically cost opportunity analysis? Awesome. From these use cases, I think uh, we want to build a data warehouse data model. So I think first would I would like to call out the entities that I would be building upon the data model. First will be the driver itself, right? Second will be the user. I think third I can call out offers, and then we can have trips. And if we have a driver, I think we will need vehicle also. There could be a partner associated to vehicle and driver. Then we can have ratings. Essentially, this will be the feedback which we share uh, based on this. And then, of course, the most important part of it, the payments. I think if you there is we all work for money, so
One quick question, sorry. What about the offer seems to be very interesting to me. Could you explain what it is?
Sure, sure. So essentially, what my understanding of a trip is that whenever I, as a user, try to book a ride, right, there is a request that goes to each of the drivers, and then once they accept it, then only it becomes a trip. So essentially, it would be an offer first to the
Hmm.
driver, and once they accept it, then only it becomes a trip. Before that, it doesn't make sense to include all of that request data into a trip. So.
Okay, gotcha. Nice.
Yeah. Should I start with the basically design of how my dimensions and facts would look like?
Yeah, go for it.
Yeah. So, firstly, I would like to call out my dimensions, right? The first dimension that I would want to look like, start off with is driver itself. In this case, my driver UUID will be the key itself. Driver UUID is nothing but the unique identifier of the driver. And then we can take up sign up city maybe. Basically, this will help us with the demographics of the driver, and then sign up city, and then we can have sign up times time. Then essentially now the we can also start with the onboarding columns, for example, which will help us with the conversion rates. So for example, I am assuming whenever we onboard, try to onboard the driver, we start with BGC, that is the background check. And then not background check, maybe first we will look for some documents, maybe start of documents, and then maybe we'll go for background check and then the final documentation. And then if everything goes out right, everything gets approved, the driver gets activated, right? So I would love to include all of those columns also into this. That is BGC approval time. Then I would actually then first go with the first BGC approval time, then
Hmm.
first, oh, I'm sorry, first document approval time,
Yeah.
then uh, and then first activation time. First, first activation time, and then actually I would want to have latest timestamp of each also. Then we can have all of this in the last, and then the current status of the driver. So essentially, he could be currently active, ineligible. It could actually be helpful to analyze that, like, if the driver was active like some time ago, and he's ineligible now, it can also help us understand, like, when he became last active, and then if he's inactive, then it
Right.
can help the users to deep dive on why is it happening now.
Yeah.
Should I move ahead, or do you have any further questions on why I made choices?
So you are capturing different times here. That is very interesting. Could you explain why you would want to do that in this dimension, opposed to using a different tables or anything?
Okay, so the the whole idea behind the driver dimension was that it this dimension should be basically it's a we can call it a type 1 dimension, because we are not maintaining sort of history of
Yep.
um, like of the driver itself.
Yep.
Driver UUID is the key, so it's just simply the same record will be updated. The whole idea behind having this is that when we also look at the conversion rate, so for example, like from BGC to doc approval to activation finally, we also would want to eventually see, that's my observation from my previous experiences, is that um, they can also become ineligible eventually and then become again active, right? So in those
Mm.
cases you will see a differentiator, or there could be um, basically a case wherein the the driver tries to become active by re-uploading a document, but they become
Yep.
ineligible. So we want to also
Yep.
capture that information. Maybe today we need activation, but in future we might need inactivation, reactivation rates. So these all those things will be very helpful when we capture this kind of
Mm,
uh,
yeah, makes sense. Yeah, yeah, that's good. That is good. The type one is really interesting because we don't really have to maintain
yeah.
history for that. That's a good type. Yeah,
Yeah.
let's move
So,
on.
and the second call out here is that I think what I wanted to call is that having history is also a kind of a burden on the user, if in case we are very much clear on what the requirement is. For me, the
Mm,
requirement is very clear that we want to look at the activation rate itself,
mm.
and I just don't want to burden the users to keep on aggregating the data based on the timestamps.
Okay. Yep.
And moving on to the next thing, then in this case, I think there is some information that I would keep, which will be kind of replicated. That is the user UID, which will be the key. Okay, the reason that I'm using the user UUID, user, not the rider, because maybe a rider would be someone who has actually signed up already, but there it could be a case where without signing up, they are just requesting rights, right? We don't want to
Mm,
lose out an opportunity to earn. So
mm,
it's better to refer to the user instead of rider. And then the current status of the user. The whole idea behind this is that we also want to capture users who maybe we want to blacklist for their certain behaviors, or their how they are behaving over a period of time. Maybe we want to blacklist them or make them ineligible for whatsoever
mm,
possible reasons. So yeah,
mm,
we would also want to capture the status of the user. This will leverage the platform itself to see the user behavior as well. Then
mm.
we will have
So can this user be both a rider and a driver, right? It can like it's kind of like a
no, no, no.
or it's like a
No,
uh-huh.
no. User is a user itself. It can only
Uh-huh.
be a rider. The whole idea is that I always wanted to keep these both things separate, even though there are
Okay.
some similarities, because
Mm,
they are different entities altogether. And I assume that the users of the data, that is the ML, and they will have separate use cases.
mm.
And yeah, it is better to keep the
Okay.
data organized. Yeah.
Okay. Makes sense. Yeah.
Then we have vehicle QUID, and then status of the vehicle. Essentially, I want to keep the status of the vehicle also, because possibly the vehicle itself is not the vehicle itself is ineligible because of maybe expired documents of the vehicle itself, right? And the if and in those cases we do not want to allow those driver to be making trips if their vehicles are uh, not available with correct documentation, or they have expired documents.
Yeah.
Then we have partner. So in this case, partner would be like any fleet partner. Maybe it could be owning a vehicle, or it could be a company which is providing drivers to the platform itself. So in those cases, I can we can have a different partner entity, and then the status associated. Then at next we can have our offers, right? Uh, So in this case, yeah, of course, like the partner UUID will be the unique key, or primary key. We can say vehicle UUID will be the primary key, right? And then in case of offers, what I would like to see, what we have discussed till now is right. Offer is something that we request to the driver, and once that offer is converted, then it makes to a trip, right? So we will have a key column called as offer UUID, unique key, okay, and then trip UUID. So this will also be unique actually, because one offer can only be converted into a one trip. It
mm,
cannot one offer can never convert to multiple trips. So that's the whole idea behind it, is that. And then offer timestamp maybe, right? Timestamp, start. uh, okay, yeah, start. I think that is something like maybe it can eventually be used to see that when was the offer made and finally when it got converted to a
mm,
trip, right? These kind of matrices also can be eventually helpful of, to see how much is the wait time for the earner, right? From the offered
yeah.
point to the time they actually get the right. So then we have trip, right? So of course it will be like a foreign key for, with the offers. Then we have trip UUID. Then of course this will be a unique key for this table. Okay, till now we have only seen the dimensions.
Mm,
Coming back to how the facts will look like, I I believe that it's the best to keep, trip as facts,
mm,
because trip will also actually include the things that, what would be the earnings and all of those things, as part of the trip itself, like what was the fare, and then whether they got any additional incentives with for the
mm,
trip itself, right? So it would be great that if we include it as a fact only. So trip UUID, trip,
yeah.
uh, who was the driver involved in the trip, um, right, driver UUID. Then we can have, um, of course, the user UUID, and of course these will also be the foreign key for, the user and the driver, right? And then we will have trip start time stamp, trip uh, end time stamp, and then we can have, trip start, trip end, the fare that was shared to the user for this, and then maybe any additional incentives that were given to the earner for the trip, uh, by the platform itself, maybe to incentivize them if they're maybe new driver or something like that. And then should we include anything else? I think this looks good to me as of
Mm,
now, right? Um, then, then finally, I think we can have payments and rating, right? So, okay, then we can have, um, right? Okay. Um, so with the trip, I think ideally we can have uh, payment UID, which will actually act as the foreign key for the payment, and then we can have payment UID, which will be the uh, primary key here, right? And then actually the payment amount, right? Essentially, what was the amount actually paid by the uh, driver? Sorry, payment amount essentially paid by the user, okay? And then payment method, and then we can have payment type, right? So, okay, and then payment amount, and then who paid it, user UUID, right? So essentially, we can on this um, this can actually help us eventually understand that given the geolocations, where the platform is earning the most, right? Like where we are getting the highest traction, or highest number of rides is one thing. Maybe you are getting more rides in one geolocation, but the payment actually is more because the people are actually traveling more distances, hence leading to higher payment amount, right? So
Yeah,
that's
kind
pretty.
of touches on our second use case as well,
Yeah.
where we wanted to do the
Yeah.
trip rejections or trip completions.
Hmm.
You have a like say the geo related analysis would be helpful there.
And then we have the ratings. Yep. So I what I want to do is that um, associate rating to a trip, because uh, a driver rates a user for a trip, a user rates a driver for a trip. So I want to keep it as one entity, and essentially it can help us eventually do the analysis in a better way, wherein we want to also see for a given trip what the experience has been for the user as well as the driver, which can actually help us with the cost cost increase our cost opportunities eventually, if we look at feedbacks properly from the users or the drivers also. So yeah, so driver rating uh, user, and then user rating driver, and then maybe complement if um, for driver, if there is a specific complement that um, is given by the user to the driver, maybe comment or driver, and then maybe we can also see a complement for user, right? Essentially, maybe if there is a feedback by the, sorry, complement for user, and then maybe we can have complement for driver, sorry, comment for user, sorry, comment user, right? So these are, I think, the basic. And also we would also want to see if the experience for the user has been so good that they have actually went ahead and given a tip, right?
Hmm.
A tip could be directly associated to the rating. If the better the rating, I think, if there's a tip involved, and of course the experience has been tremendously good for
Mhm.
the, right? So
So should we also have a rating UID here for the rating table?
actually, the thing is, initially I was not thinking of having a rating UUID as such, because that will actually be a simple lookup table wherein rating UUID would have just like ratings from 1 to 5.
Mm-hmm.
Eventually, I don't see that changing. I feel that it is going to be something very static. What that is my observation. Do you think otherwise? That's why I was
No,
not planning.
no, not about the rating. So yeah, the rating is a column. The rating
Mhm.
UID, what I was referring to is more of a key for this table.
Oh,
Uh,
awesome! Actually, good call out.
because the trip, so you will have a same, I mean the whatever we qualify a driver rating as a separate rating ID, and then a user rating as a separate rating ID. It will have two different columns, but the trip would be same. So, right. So for the same trip, both may rate at a different point in time. Is what
Mhm.
I'm like. What I'm is that the? I'm not sure if that is your. understanding as well, but that's what I was understanding. So curious
Yeah.
whether we should have that information as
Yeah, actually, the thing is, the whole idea behind it was that again, this was supposed to be a type one dimension table wherein, in this for the same trip, if there is an update, for example, driver gave the rating to the
well.
user on day one itself, and user is giving rating to the driver, or maybe on the 10th day, the data
Mm.
should be updated in this table itself, making the trip with a unique key, right?
Okay.
Uh,
Hmm.
yeah, that's what. Uh, idea I had it in my mind. Um,
Okay.
yeah, if I would have actually planned to do it in a different way, wherein with the trip I want to make rating UUID, then I can
Mm.
maintain it as a key value kind of format, wherein key could be driver rating user and then the value
Mm.
with it, and then but in this case I'm having it as it a separate column itself.
Mm.
I think I can.
Yep.
Thank you for calling this out. It's a good point, actually. But in this case,
Mm.
I'm making this decision to have one row for each trip. So I
Yep.
think I can live with this kind of data
Okay.
model.
Yeah. Yeah.
I think that I have included all the entities possible. Uh, I think I should be able to include all the use cases, and I've also tried to foresee what future use cases could come and design the data model according to that. Uh,
Yeah.
does this look good, or do you have any
Yeah. It
feedback?
looks good. I think we are on time. Yeah. Let's move on to the next section.
Okay. So given the data model, and we would also be, of course, the ultimate goal is the query
Yep.
capability, right? So
Yeah.
given the case, first is the conversion rate, driver conversion rate. We also we want to see, like, uh, given from the sign up, like how much time they are actually taking from sign up to activation rate, right? So in this case we can simply go ahead and refer to the driver table, and actually do check wherein um from the sign up how much time they are actually taking to uh, basically uh, sign up time. So this is a high level logic that I'm giving. It's kind of a
Yeah.
pseudocode. Yeah. Okay. And then cyanide, this I can call is like the time actually. I can call it the BGC. Uh, BGC rate, because it is, if it is taking like more than like a 10-15 days, right, then of course there is
Mm.
something we would want to look at, right? In
Mm.
the same way, sign up to uh, of course, like docs approval, because these things can happen in parallel. Dogs approval, uh, approval time, and same way we can call it as um, uh, doc approval rate. Then eventually, yes, sign up to actual activation time, right? Sign activation time, sign up time to actual the activation time, and then it could be activation rate, right? So this will actually give us the high level overview of how the sign up to activation rate looks like.
Yep.
And then also, okay, then we would also want to look at the uh, trip request to completion rate, right? So in this
Mm.
case, I think I would like to look at two entities at least. That is the user offer, and then another third entity, which is the trip, because we want to see how many offers are actually getting converted to trip, right? Uh, and
Yep.
yeah, so second from uh, first trip, because no, actually the offer, then left, it will be kind of left join with trip, right? Um, offer dot trip UUID is equals to um, trip dot trip UUID. And then, of course, I would also want to join trip with the user to avoid any blacklisted users, right? Um, trip, sorry. Okay, then we can directly have left join user trip user where it is equals to user dot user UUID, where status of the user uh, is actually active. Essentially, the whole idea is that we want to avoid blacklisted ones, uh,
Hmm.
because then it could actually go ahead and impact our metrics.
Yeah.
Blacklisted users should not be part of requested versus this thing,
Nice.
completion metrics. And then we want to see by the user, right? Um, then we will have our key as user UUID, which will come. Um, okay, actually, no. The user UID should come from the offer itself, and then sorry for the miss from my side. It should be the user UID also here, because that is the person who is making the request here. So offer dot user UID, and then uh, maybe count of uh, offer key. Okay, offer dot UID, and then mm, count. Okay, maybe I just want to put a case where case when um, trip dot user, or maybe a uh, trip dot user UID is not null.
Hmm.
It's not null only then trip dot user UID, else it should end, and then give me all those count only. And then okay, okay, if I just simply want a percentage, I think I would rather expect it put the offer in denominator, and then this could actually give me a percentage uh, of the given a user UID. What is the percentage of offers to trip conversions?
Yep. That's looks good. I think the left join does the trick here. When
Yeah.
you have the trip ID, so when the offer is not converted into the trip, then the trip you are not populating the trip UID in the offer table. So
Yeah.
that helps you in this column. That's good. I think this one we can extend even to not specific to user ID. If we want to get metrics of how many offers overall were converted
Hmm. Yep. Yep.
uh, into trips, and then how many were not. That is another use case that we can do.
Yeah. Yeah.
Oh,
Correct. Correct. Yes, makes sense.
yeah, that's good. And like say if just yeah, just out of curiosity, if I want to say, for example, you have you're getting offer and trips, and then I would want to include some geo,
Hmm.
which I think your offer table currently
Hmm.
do not have, or maybe I missed it. Do you have an option to, for example, from the location wise, if we want to find out how many offers we have got from each location, or which has got a higher number of trip conversion, that
Hmm.
is
Hmm.
also a use case that we can look at for profitability.
Yeah, yeah.
Uh,
It's
well,
actually, this is something that has been missed here. There should be another entity which I'm actually I realized in between the interview itself, that there should be a location entity as well, wherein
mhm.
each of the trip can be tagged to a location, and then based on the geolocation also we can make where the density of the trips is higher and where the opportunity, earning opportunities are higher. Yes,
Yep.
of course, that would be really helpful if we can include the location entities.
Amazing. That's good. That's good. I think this is a good time to pause. Uh, Probably, if you could share, given if you are an interviewer, and then if you could share what went well and what would you have done differently?
So I think what went well was that in the start itself, we clarified the exact requirements, right? And once we had clarified the requirements, we that played the biggest role in helping us design the data model itself. Because once you know the use case, everything eventually falls into right into place. Because from the use case itself, we were able to identify that we are looking at driver entity, we are looking at trips, we are also looking at users, right? And then if it's a request, then of course offers. So I think from the start itself, we had the clarity on how our data model will fall into place given the requirements. I think that went well. And also, what I really like in the interview is that it is always a collaborative effort between the interviewer and the candidate itself, which I think which went well between us, since you were always available for the feedbacks. And I think which since the feedback was always on time, I was able to work on my data model better. um, what I could have improved on is something, yeah, which was later called out by you, is that geolocation is actually one of the very key factors when we come to the ride sharing app. And I think even though it was not mentioned in the use cases, this is one of the common asks that once we have clarified the requirements, that location is something that which can be looked on next. I think
Yep.
could have foreseen that requirement and then build my data model on top of it accordingly.
You did really well. I mean, I think the thing that stood out is like we were able to uh, take the use cases, scope it out, and then the icing on the cake was you finished out with a query as well to exemplify how the analytics look like. Thank you so much for joining us, Kajal, and thank you everyone watching. Until next time, good luck on your next interview, and thanks for watching.